These are the notes for Target 5 in the energy unit that states, I can analyze how the total energy score in a system remains the same using the law of energy conservation. All right. This statement, the energy score in the universe never changes. Kind of try to brainstorm what that means. Okay, when you hear the word score, I think most of us would at least think of a number. Okay, so this is quantitative. And so when we say a number, that's an amount, right? If Michigan loses to Michigan State basketball by a score of 60 to 30, okay, we know that there's a quantity of 60 points and a quantity of 30 points. So the total energy score in the universe never changes, means the number of something. The number or the amount of energy never changes. And that should go against kind of your common sense a little bit. We're going to provide a lot of examples. But from the pendulum gizmo, from the work that we've done together within class, when I write down the word TME, hopefully we know by now that's total mechanical energy. Remember, that just means moving parts. All right, so almost everything in this universe has something moving, so total mechanical energy. And remember, the way that we came to that number was by adding potential and kinetic energy. Now, when we did pendulums and roller coasters and swings and all that, or possibly today, depending on if you're in class, it's going to be skateboards. We always talked about gravitational, so being above the ground, GPE. Kinetic just means something moving. Something is moving. It's this law of energy conservation that supports or provides evidence to show how that total amount of energy never ever changes. So the law of energy conservation. And the first kind of component of it, so the first part, capital E for energy, no need to write that out all the time. So energy cannot be created or destroyed. Energy cannot be created or destroyed. Let's think about that. All right. My favorite thing in this whole world is to go camping. And if we've got some wood in a campfire, get ready for these drawings. You know they're going to be good. So here's our wood. Hopefully my campfire setup is a little better than that. Here's my flame. That's horrible. But if I have to keep throwing wood on this fire, right? Because this wood, it disappears. It looks like it's destroyed. If you've got a 6-year-old camping with you, they're going to say the wood is gone. You destroyed it. All right? Well, similarly, somehow that wood got created too. And so when you look at this, at first you're like, destroyed the wood, and somehow the wood was created, so it looks like this is false. All right? But the reason it looks like it is false is because of the second and third parts. These second and third parts almost explain this. We can transform energy. So think of, Transformers, the movie, or maybe you had a Transformer as a kid, or maybe you still play with Transformers. But that starts out as a robot, and then you transform it into a car, and now it's a car, and then you can switch it back into a robot. So let's see here. Transform energy. That might start to make a little bit more sense here with the fire. Well, we started with chemical potential energy, CPE, chemical potential energy in the wood, because it was stored in the bonds. We broke those bonds, and what did we get? Well, we got smoke, Lentz. All right, smoke is just particulates. It's all this stuff broken up. All right, so we have smoke that goes up in the air. We oftentimes light campfires because we can make marshmallows in campfires, and we can stay warm. So we know, we've got thermal energy. Okay, so thermal is coming off of the campfire. Okay, it's giving that off. So we're taking this chemical potential energy and we're transforming it. We're changing it into thermal. Okay, smoke isn't really a type of energy, but it has a smell to it. So we know that it's broken into other parts, okay, because you can smell that. And for right now, we'll just say, we'll go particulates. That's just little things. All right, but it's turning into something else. That's the bottom line. There's radiant because it gives off light. So there's an example of transforming it. It's that time of the year where they're selling candy bars for 6th grade camp. A lot of you probably remember these. So let's say that we have a candy bar. Candy bar, chemical potential energy. Okay, there's sugar, there's fat. I don't know that there's any protein in here, and now I'm curious. Oh, there's 2 grams, so that makes it health food somehow. All right, so we have this candy bar. You ingest it. You break it apart so that you can live, okay, or any type of food. So we break it apart, and now all of a sudden our heart is beating. There's our kinetic energy. We're giving off thermal energy. We can talk. There's sound energy. We can keep going on and on. Okay, that's transforming this energy into something else. So again, this candy bar was created, but what was it created from? All right, so hopefully you're starting to pick up on this. The third thing, we can also transfer energy between objects. Okay, we can transfer energy between objects. So I've tried to draw this before and it just never goes well for me. So I'm just going to say, in your hand, you are going to hold an ice cube. Okay, so you're going to have an ice cube in your hand. If you sit there long enough, you could get that ice cube to totally disappear. And I don't mean just turn into liquid water. Like if you stood there long enough, it would evaporate. So if I put an ice cube in your hand in the morning and came back after school, there would be nothing there. So it looks like, it was destroyed. Okay, but really all that was happening is that thermal energy was transferred to the ice cube, and that caused it to become liquid water. Okay, because ice cubes are technically water anyways. So it became liquid water, and then we had the sun, happy sunshine, and that turned it into a gas. And we can't see it anymore. But we do know that energy was transferred through a system. Okay, so we can move things around. If you touch a hot pan, energy is quickly transferred into your hand. You remove it, right? All right. So, last thing regarding this energy idea has to do with the process of efficiency. Because there is no such thing, it's impossible to have 100% efficiency. And we all strive for it, hopefully, right? We like to use all our time wisely and not waste time, but 100% efficiency is impossible because of energy transfer and transformation. So how we often think of it is in terms of energy input and useful energy output. Here's an example. I was out exercising this morning. Gas jumped to 285. 285 a gallon. An average vehicle. All right, and this is just an average. So an average vehicle is 33% efficient. I'm not talking my niece's Volt. All right, her and her husband's Volt car. I don't know. That thing's crazy efficient. So I'm not talking a Prius zipping up and down the street. I'm also not talking a big old muscle truck with flags flying and huge tires and smoke rolling out of dual exhaust and, hairy men driving it. So I'm not talking that one either, all right? So don't go on either extreme here. What we're talking about is something right in the middle, just an average truck, average car. So let's say that, and there's no saying, if anybody wants gas today, at least in Shepherd, you got to pay $2.85 a gallon. Here's the depressing part. Of that $2.85 a gallon, if we multiply that by 33%, 94 cents is useful. So only 94 cents of that $2.85 is being used for what you actually want it to be used for. Make the tires move, help recharge the battery, keep my radio on, all right, all those things. The other, so out of that, 285 minus 94. The other, $1.91, this is a slight exaggeration, but not much, out the tailpipe. So because of all the moving parts within that system, a lot of that useful chemical potential energy from the gas is being wasted. Okay, so you're producing a bunch of thermal energy. Think about the vibrations that have nothing to do with actually moving the tires. Right, so the sound that's given off. Okay, that's technically useless energy, so it goes right out the tailpipe. So energy conservation says that total energy score, total amount of energy in the universe, you will never change it. Okay, we can't change it. We can change it into something else. Okay, we can change its form. We can move it between different systems, different objects, but we can never get rid of it and never make new. And that is all. Good luck.